Okay, so what we're going to do today is write a polynomial function in standard form if we know what the zeros are. And remember, the zeros are the x-intercepts. So we've got a theorem, and there are a lot of theorems related to polynomials that we're going to use, and I'm sure you remember theorems from geometry, but these are algebraic theorems, but so useful to help us get things done. So the expression x minus a, where a is just a number, is a factor of a polynomial if and only if the value a is a zero of the related polynomial function. So here's what I am saying. If 5 is a zero, then x minus 5 is a factor. Okay? So in this example right here, it says, what is a cubic polynomial function in standard form with these three zeros? And we kind of talked about this when we were doing our unit on quadratics. And so if I have these three zeros, then my factors are going to be this. The negative 2 gives us the factor x plus 2. The positive 2 gives us the factor x minus 2. And the positive 3 gives us the factor x minus 3. All right, and here's where this comes from. And we did this when we did quadratics. We know, for example, that x equals negative 2 is a 0, right? The way to make that into a factor, add 2 to both sides, and you end up having x plus 2 equals 0. And remember, in factored form, this was how we found our zeros, is to figure out what factors we had and set them equal to 0. That's where we get our x plus 2 from. So now that we've got these three factors, we've got to write this in standard form. And at the end of class Wednesday, we actually did this on the board. The first thing you're going to do is use some FOIL. Okay? Can't FOIL 3, got to do 2 at a time. So we're going to do just these two. And when you FOIL these, can I get you to agree that this is x squared minus 2x plus 2x minus 4? Fair enough? Okay, we got to combine like terms, and these guys actually cancel. And so we have x squared minus 4, and I'm going to bring down that x minus 3. And again, I'm going to FOIL. So when I FOIL this, I've got x squared times x gives me x to the third. X squared times negative 3 gives me negative 3x squared. Negative 4 times x gives me minus 4x. And negative 4 times negative 3 gives me plus 12. Now, when you do FOIL, your terms may not be in standard form order, which means highest to lowest exponent. If they're out of order, you got to put them in order, okay? But ours are in order here. So this is your polynomial function in standard form, and you are done. All right, so let's try that again. We're going to do another example right below here where we're going to do a quartic polynomial function in standard form with these zeros. Now, I am a little strategic about how I do this, so bear with me. I'm looking for the easiest way to accomplish this, because when I do this, look what I have. A negative 2 is going to give me an x plus 2. A negative 2 is going to give me another x plus 2. A 2 is going to, gives me an x minus 2. And a 3 gives me x minus 3. Now, when I am multiplying this all out, my strategy is to try and make this as painless as possible. If you ever have an A plus B, A minus B situation, like you do right here with these two, do that first, because the answer will give you a binomial instead of a trinomial. All right? So my first thing is I'm going to do these, and I know that this is x squared minus 4 when I FOIL that. So here's what I've got. X plus 2. I've got an x minus 3, because it doesn't matter what order they're in. And I've got an x squared minus 4. Okay? Pick any two of those, go again. So I'm actually going to pick these two right here, and I'm going to go again. And I'm going to FOIL. And when I FOIL, I'm going to get x squared. When I do my inners and my outers, because they're going to be like terms, notice I have negative 3x and positive 2x. That gives me negative 1x, right? So minus x minus 6. And then I have x squared minus 4. Now, this is where it gets a little bit trickier. What you have to do at this point is everything in one polynomial has to multiply by everything in the other. So in other words, this guy here, I'm multiplying by all 3, and this guy by all 3. That's going to give me 6 things, and then I got to combine like terms. So x squared times x squared is going to give me x to the 4th. And then I've got x squared times negative x gives me negative x to the 3rd. X squared times negative 6 is minus 6x squared. Go to the 4. Negative 4 times x squared is minus 4x squared. Negative 4 times negative x is plus 4x. And negative 6 times negative 4 gives me plus 24. Combine like terms. So I have y equals x to the 4th minus x to the 3rd. These two combine and give me minus 10x squared, then plus 4x, and then plus 24. There is a quartic polynomial, and you have written it from its zeros. Okay? Now, yes?
So this feels like a really dumb question, but like in the beginning, can you just kind of combine stuff like x plus 2 and x plus 2? Can you just make it x squared plus 4?
It's not, though, because you have to FOIL that. When you FOIL it, your inners and outers are both 2x, so that's x squared plus 4x plus 4.
Oh, okay.
In which case you have a trinomial, which is fine, but I try to find the a plus b, a minus b's, because they form binomials instead of trinomials, which is just easier to multiply, easier to FOIL out later on.
All right.
It wouldn't matter what order you do it. It'll all come out the same in the end.
Okay.
But just be aware, that is x squared plus 4x plus 4. Now, hang on one second. Something I want you to know about when this graphs, because I'm surprised no one asked this. Why did this 0 of negative 2 happen twice? What the heck is that? Why twice? Why twice, not once? Okay, so would you agree this is quartic and the A term is positive, so this is up, up, and it should, when we graph it, go like this, right? Yes. Okay, now, here's the assumption. Here's the x-axis, and you see how we have 1, 2, 3, 4 x-intercepts. The situation where we've got 3 different ones and a repeater is this situation. 1, 2, 3. When it repeats, it is not crossing, it is touching and bouncing off. So this point right there, it's touching and bouncing off. So if I go to graph this, here's the negative 2, here's the 2, and then we've got the 3, would be something like this. This one's twice, so it's not crossing there, it's bouncing off. So it's coming down, bouncing off, coming over here, crossing, crossing, and up. Okay? So you can see right there, this is at -2. It doesn't actually cross, it bounces off. That's what happens if you have a 0 that occurs twice. And what this is actually called, when it occurs twice, is a double 0. Double 0. Yes?
Are we ever going to have to FOIL trinomials? Can we, like, in the homework?
Like three of them? Well, you did have 2 and 3 here.
Well, that's 2 and 3, but are we ever going to have to, like, 3 and 3?
Yes, and in which case you'll have 9. But then you'll have 9 things, right? 9 terms, because each one of the 3 has to go with each one of the 3. So you'll have 9 terms, but you'll have a lot of like terms that will simplify it down. Yeah.
Okay.
Yes, that could happen. Okay. Ooh, this was all about multiple zeros. Okay. So it says you can write the polynomial function in problem 3 in factored form as this. And this was the second one. And that's what's interesting about it. See how x plus 2, they wrote quantity squared? Same thing as writing it out separate. In g of x, the repeated linear factor x plus 2 makes -2 a multiple 0. And specifically, in our case, it's a double 0. Here's another important piece of information. If a is a 0 of multiplicity n in the polynomial function, then the behavior of the graph at the x-intercept a will be close to linear if n equals 1, close to quadratic if n equals 2, close to cubic if n equals 3, and so on. And I'll just tell you, I get that that's really difficult. The thing I want you to understand is that one time crossing the x-axis is a single 0. Okay? Just cross. If it bounces off, that is a double 0. All right? We're going to go on to finding the multiplicity of a 0 right here in the next problem. And the first thing you're going to want to do here, it says, what are the zeros of this function? Do you remember how we find the zeros?
The x is equal to 0?
Well, you set the function equal to 0, so this is what you'll do. You'll have x to the 4th minus 2x to the 3rd minus 8x squared, and you'll set that equal to 0. But now what do we do?
Divide by x.
No.
Oh, okay.
Factor. Factor. So the first thing you're going to look for is, do I have a greatest common factor? That x to the second. So we're going to factor that out. X to the second, which leaves me with x to the second minus 2x minus 8. Now this is an easy one to factor. What multiplies to -8 and adds to -2? -4, +2, right?
Yeah.
Okay. So x squared, x minus 4, x plus 2 equals 0. So you now realize that you could have x equals 0, x equals 4, and x equals -2, right? And these guys are your zeros. This guy happened once. The multiplicity of this 0 is 1. So under here, let's do this. Multiplicity. 1. This factor happened once. The multiplicity of this 0 is 1. This factor, the x, is raised to the second power. This happened twice. So when you look at this graph, you will see at -2, it passes through. At 0, it doesn't pass through, it bounces off the x-axis, and at 4, it passes through. What does what mean?
Multiplicity is.
Multiplicity means how many times did that 0 occur in your factored form.
Oh, okay.
So the factor of x occurred twice.
Okay.
The factor of x minus 4 occurred
So
once.
it's when it hits and bounces off.
And when the multiplicity is 2, it hits and bounces off,
Okay.
as opposed to passing through.
Right.
Okay. So let's do one more. We'll go down here to the bottom of the page and do the next one. So let's find the zeros, which means let's set it equal to 0. First step,
Factor out of x.
factor out of x, which leaves us with x squared minus 4x plus 4. And how does that factor?
X 2 or negative 2. Negative 2.
Negative 2. So may I encourage you now to do this? Because you just told me negative 2, negative 2. Well, instead of writing it twice, I'm just writing it once with squared. All right? So, my zeros are 0 and 2, right? And my multiplicity
Is 2? Would it be like 4 or something?
1 and 2.
this guy only occurred once, this guy occurred twice. So at this point, it would bounce off. So if I wanted to graph this little beauty, now this is cubic, and the A is positive, so this looks like this, right? I've got a 0 at 0, and I have one at 2. It's going to pass through at 0 because the multiplicity is 1. It's going to bounce at 2 because the multiplicity is 2. So I can now tell you it's going to look something like this. Pass through, bounce. Okay, last page. The graph of a polynomial function has several turning points. The function can have a relative maximum and a relative minimum. Would you agree this is not really a maximum because the function does go much higher over here. So what that's called is it's a maximum, but it's a relative maximum. And this is a minimum, but it is a relative minimum, okay? So relative minimum and maximum. So what are the relative maximum and minimum of this function? Let's go through this in our calculator one more time. And so the first thing that you're going to want to do is go to your y equals. Do this along with me and put your function in. So I'm going to have x to the third power plus 3x squared minus 24x. And I'm going to hit enter, and I'm going to go to the graph and see what I can see with this thing. Oh boy, that's a mess. I need to see those a little bit better. So what I need to do is give myself different y max and y min so that this fits better. So I'm going to go over here and change my y min and max, and I'm going to try and do this negative 50 and 50. Thank you. All right, and let's see if I can get this on here. Well, I got one. So we can stretch this in a minute to get the other one. Let's go ahead and get this one. We're going to get this minimum right here. This is a relative minimum. So go second calc, and what we want to do is get that minimum. So we're going to pick minimum, hit enter. It asks us for the left bound, so all you want to do is be on the left-hand side of that minimum and click enter. Now it says right bound, so you're going to go on the right-hand side of that minimum over here and click enter. And it says guess, so you want to go and try and sit right on that minimum and click enter. And it tells me that my minimum, it looks like 2, so it's the point 2, negative 28. And that is my minimum. Do you want me to do the maximum with you?
Yeah.
Okay, so go back to our window because we got to get that part of our graph in there. So I'm going to change my Y max to go up to 100 and see if I can pick that guy up. And there he is. Okay, much better. So here's what I'm going to do. Go to second calc, and this time we're picking up a maximum. So choose maximum. It says left bound, so I want to go over to the left side of my bump, and I'm going to click enter. And then it says right bound, so go to the right hand side of the bump and click enter. And then it says guess, so go sit right on the bump and click enter. And it tells me that my maximum, the X value is -4, the Y value is 80. So this right here is my maximum value.